Okay, so just a little bit more work on using summary statistics, still from chapter 11.5. So one of the questions that was set for homework was question 6 from 11.5. So you needed to plot this on the calculator and you should get some side-by-side box plots. Now, you can check the answers for this at the back of the textbooks, so I'm not going to go through that. However, it also asks you to come up with some conclusions, so that's what I want to talk about now. So what types of things can we talk about? So in this case, we could say something like, as Q1, the median, Q3, and the maximum have all reduced or gone down, we can say that this program that they're talking about here actually shows some level of success. So in a lot of cases, you're not going to be able to make definitive or definite conclusions, but you're going to be able to say that, just like in this one, it indicates this. So in this case, it said it's showing some level of success, and the reason it is showing some level of success is these values have decreased. Or you might have the opposite situation, these values have increased. So this shows that whatever it is that relates to the question that you're working with. So don't think you have to come up with a definite answer necessarily. It's asking you to discuss what the graph and the data is showing, not necessarily say this is absolutely what's happened. Sometimes we're talking about trends as much as anything else. Okay, now just a little bit more. So which ones do you choose is what I want to talk about now. Which values do you choose? Because we've looked at calculating a whole lot of different values. And you need to, different ones are relevant in different situations. So which measures of central tendency and dispersion should be used depends on two main factors: the nature of the data, so that's what kind of data is it, and the proposed use of the measures. What are you trying to do or find out? So let's just talk about some things. So the properties of the mean, median, and mode. So for large data sets of symmetrical distribution, so that means evenly spread, the mean, median, mode are all about the same. So it really wouldn't matter which one you use. However, there are some things that are going to be more specific here. So the mean and median cannot be calculated for nominal data. So remember back what nominal data was? It doesn't have particular values necessarily. So you would be interested in how many times things occurred. So mode is the one that you would use there. Mode, nominal data, mode. The mean may not be a sensible distribution for some sets of discrete data. Remember, discrete data can only take certain values. So when we're talking discrete data, you would likely use the median or the mode, not the mean. So again, depends what you're working with as to what you use. All the data is used to calculate the mean. So that could be useful when you want everything included. When you want everything included. Okay. The mean, however, is affected by extreme values. So outliers is what they're talking about there. Things that fall far outside the data, the mean is heavily affected by that. Median and mode are not affected. So if you have some outliers that you think are a bit odd, you would not choose the mean to calculate information about your data. So the mode is the most probable value if an item is chosen at random, the one most likely that you're going to get. The median is the one in the center, so the most central. The mean is the most commonly used measure. We use mean in lots of different things, and you would have seen that in lots of subject areas. Mean or average, commonly used in lots of data. Not always appropriately, but it is used a lot. Now, we also need to talk about the properties of the range, interquartile range, and standard deviation. When do we want to use them? So the range measures the overall spread from the minimum to maximum, how far the data goes. The interquartile range, we're only looking at the spread of the middle half of the scores. So the scores from Q1 up to Q3 in the middle. That's what we're interested in, because maybe outside of those are outliers that aren't really going to be useful for us. So often the interquartile range is more appropriate. Standard deviation is something like the mean that's based on all scores, and it's something we would use when we're making comparisons between data sets, because it uses everything. So comparisons, mean and standard deviation. And it's a really commonly used measure of spread. You would see it listed in lots of things, particularly science things if you do anything with science. So what I thought I would do now is to go through a question that uses mean and standard deviation. So there's some questions there for you to do. Exercise 11.5, question 12. But I'm going to go through the answer for question 12. Please practice this stuff as well. You need to not only be able to calculate these values, but you need to be able to talk about them. So they're important. So question 12 asks us to do a comparison and come to some conclusions. And we're given some information. So we're told that for Haseem, one student, in Maths A, he gets 56, and in Chemistry, he gets 45. We've also got David. Now in Maths A, he only gets 48, and in Physical Recreation, or it would be the PE equivalent, he gets 56. So you can see the numbers are quite different. Now we're also told, to help us come to a conclusion, that in Chemistry, the mean is 55 and the standard deviation is 8. And in Physical Recreation, the mean is 60, so you can see the score's higher already, and the standard deviation is only 5. And remember, standard deviation talks about how far the next group of data is from the mean. So one standard deviation in this case, this one here, one standard deviation above the mean would be 55 plus 8, or 63. 63 marks would be one standard deviation above the mean. So let's write something about that. So standard deviation measures the spread of scores from the mean. So when we're talking about the boys' scores, we want to know how many standard deviations they are from the mean, because we've got 3 different subjects here and they don't even take all of the same subjects, so we can't directly compare them. So we need to use that mean and standard deviation and how far away or how many standard deviations they are away from the mean to come to some conclusions here. So let's look at those now. So, I mean, we can directly measure the Maths A marks, definitely, but Chemistry and Physical Recreation, we can't do that. So in Chemistry, Haseem is 10 marks below the mean. How did I calculate that? So it says up here that Haseem got 45 in Chemistry and the mean for Chemistry is 55. So he is 10 marks below the mean. So we want to know how many standard deviations that is. So the standard deviation for Chemistry is 8. So how many times can we take 8 out of 10 is what we really want to know. And we can just turn it into a fraction to do that. So part, whole, just like we've done before, we divide 10 by 8. How many times can we take 8 out of 10? 1.25 times. So that means his mark is 1.25 standard deviations below the mean, below the average score. Now, let's do the same thing with Physical Recreation. So David, in this case, is only 4 marks below the mean. Now, where did that come from? Let's go back and look there too. So the mean in Physical Recreation is 60 And David got 56. So that is calculated by going 60 minus 56. And we're going to do the same thing we did here. He got 4 marks, and the mean in the standard deviation physical recreation is, 5. So how many times can we take 4 out of 5? Obviously it's less than 1. In this time it's going to be 0.8 times. So that means he has 0.8 standard deviations below the mean, which you can see is less standard deviations than Hasim is below the chemistry mean. So we need to be able to talk about what does this mean. So what it means is this. Hasim is more standard deviations below the chemistry mean. So that's where I'm saying 1.25 than, and you can see than is the comparing word here, then David is below the physical recreation mean. Physical recreation mean, because he was only 0.8 standard deviations below that. So what does that mean from that as well? So we could say from this, so because Hasim's marks are better than David's, in Maths A, maybe Hasim is smarter, possibly. Could also just mean he was having a better day, couldn't it? Or he knew the topics better. Anyway, we could also possibly say maybe chemistry is harder than physical recreation as a subject, because, and maybe we think this because Hasim's mark is further away from the mean. Than David in physical recreation, and we know that maybe he's smarter because he got a higher mark in Maths A. Now, can we say this for sure? No. So, Hasim's claim could be true, but to say that, we would need to make a lot of assumptions. Need to make a lot of assumptions. And the types of assumptions we would have to make to say that could be such as the classes being tested are of a similar ability level. What if you have in chemistry a bunch of really, really high achieving chemistry students, and that's why David was further away from the mean in that? Do we know that? Not really. So, can we really say that from the information that we know? Not really. And that is the problem with a lot of these questions. So we can't really prove either way from what the information we have has been given, but you could certainly make some statements about what could possibly have happened, but you would need to justify that, saying, to say this, we've assumed this. Like, we've assumed that the classes are of similar ability levels. So you can see it's not really a definitive answer, which I know some of you don't really like in maths, but sometimes that's what happens. Okay, hope that makes sense. If not, please ask me. See you in class.